Okay, so this is the final portion of our Chapter 2, Section 2 notes, and just notation that you need to be used to. So V-bar, Mr. Walker's famous. V-bar is distance over time. You are familiar to that. What I grew up doing was the rate equals distance over time, and average velocity, this is big. Average velocity, that is what you have worked with your whole entire life. That is the rate of change of your distance. So S is your position function, it's where you're sitting. And delta means rate of change. So this is your change in distance over, and then delta again is change. So this is the change in time. Okay, so seriously, change in distance over change in time. What that is saying is we're looking at S minus S, the distance things, over T minus T. Well, what's that look like? That hopefully looks a little bit like slope, which would be y minus y over x minus x. So average velocity, V bar, rate, those are kind of like derivatives. Now, average is not a derivative. Instantaneous velocity is a derivative, but average velocity from one point to another is just the change in S over change in T. Instantaneous velocity, however, is going to be your first derivative. So if we want an immediate rate of change, we want to know exactly how fast something is going at a certain place. Here is an example for it. So a billiard ball is going to be dropped from a height of 100 feet. Height S, again, position function, at time t is given by the function listed below. S equals negative 16t squared plus 100. T is going to be measured in feet and time in seconds. T is in seconds. We're supposed to find the average velocity, so average rate of change, slope, between the given intervals. So we're not going instantaneous velocity yet. We have not been asked to do a position or a derivative. We just want the average rate of change. So what I have to do here is I'm going to put 1 in. These are your domain values that you can use. You can use 1 and you can use 2. That's not an ordered pair. So if I put 1 in, I get 1 going in is negative 16 plus 100. And so that's going to give me my, what is that? 84, I believe. Hopefully that is correct. If I put 2 in, I'm going to have negative 16 times 4 plus 100. 16 times 4 is 64. So 100 minus 64 should be 36. So that point would be 2, 36. I hope I have the right values on those. Check them, you guys. If not, just pretend I have done the math right on those. Then, if I want average velocity, average, not instantaneous, average, that is my change in position. So 84 minus 36 over the change in time. So 2 minus 1. So my average rate of change is going to be 48 over 1. And so in this case, it's feet per seconds. So average velocity is 48 feet in 1 second for that particular set of coordinates. Set of coordinates. That's at 1, 2. So your next set of coordinates that they're going to want us to use is going to be 1 and then 1.5. And I desperately need, I'm not going to be able to do that in my head. So I'm pulling out a calculator here. So at 1, I already knew that. At 1, we put that in and we had our 84. At 1.5, I'm going to pause and type that. All right, so I put in the 1.5 for the t up there. And when I did that, I got 36. So my average velocity, my rate of change from 1 to 1.5 seconds is going to be 84 take away 36 over 1 minus 1.5. You know what? Did I go backwards on the other one? We're going to go back and double check if I didn't go in order. So 84 take away 36 is going to give me 48 over negative 0.5. Now 48 over negative 0.5, excuse me, is, oops, I hit the wrong buttons. Should be negative 96, but I'm going to double check. Yeah, it is negative 96. So my average rate of change here is negative 96 feet per second. So it is dropping. That ball is dropping at a rate of negative 96 feet per second. So the negative just means we're dropping. I think I dropped my negative on this side. Yep, I definitely did. We're going to fix that. So if we look at that, really if I start with the 84, I needed to start with the 1. You probably caught that. But all it's going to do is make it negative, meaning it's dropping at that rate. So that's an easy enough fix. Okay, continuing on here now. Now we're going to find the average rate of change just between 1 second and 1.1 seconds. So we just got to type that in again. So I'm going to get those back. So I put the 1.1 in for t, and I got 80.64. So now if I want the average velocity, or the rate of change from 1 to 1.1 seconds, I'm going to go from 84 to 80.64. And then that's going to be 1 minus 1.1. I'm doing that better this time. I made sure I put it in the correct order. And 80 minus 80.64 is 3.36. This will be negative 0.1, which I believe, yep, I was going to say it's just going to move our decimal point over, but this goes to negative 33.6 feet per second. So my average rate of change is negative 33.6 feet per second. Now that's kind of interesting because, all right, in 1/10 of a second, the rate of change is 33.6. In half a second, it was 96 feet per second, but in 1 full second, it's 48 feet per second. So we changed a lot in 1 second. That is just the rate. So it's like it started slower and then it took off and then it went slower again. So my rate of change, my speed, is not remaining consistent in any way, shape, or form here. So here is what we know. Speed is always the absolute value of our velocity. We cannot have a negative speed no matter what we're going to do. So the position function for any free-falling object is always going to be of this type of formula. And if you're in physics, you actually have probably already used it. So your position, the place that you are currently located, is always 1/2 the force of gravity. So G stands for gravity. Initial velocity ends up in front of your time. And this is the starting position, where you're going to drop from, where you're going to start from, whatever you're going to do. So this isn't, and I'm going to move the little green boxes so you can actually see what it's saying. But, so A, gravity, and if you're in feet, it's 32 feet per second, so you would go with negative 16 in front there. And that's what you probably have seen on all of our math equations that we've done from here on up. And then in physics, I know you go in meters. So this would be half of 9.9, and so you're going to see the 4.98? Nope. 4.95. Negative 4.95 in front of that. And then V sub 0 is your initial velocity. S sub 0 is the starting height, starting position, starting whatever it is we're going to look at. So here we go. Oh, and I should have told you, if we wanted instantaneous velocity on this one, I know this is not part of the notes, but instead of average velocity, if I want to know at any point in time how fast we are going, all I need to do is take the derivative of this function. So S prime is negative 32t. So the actual rate at exactly 1 second, that this billiard ball is falling. So at 1 second, I do negative 32 times 1, and I get negative 32 feet per second. So it is dropping at a rate of negative 32 feet per second. If I put in the 2 seconds, at 2 seconds in, it's dropping at a rate of negative 64 feet per second. Just so you got that in there. But coming back over to where we were now. So at time t equals 0, a diver is going to jump from a 32-foot platform. So we're in feet. This is starting position, and then we're in feet. So what we're supposed to do is try to figure out when the diver is going to hit the water. So here's what I know then. This is the function that they give me. I knew I would be in feet. So there's half of gravity, starting position, and then that is his initial speed. Right now, you do not know enough to go backwards and figure that one out. So they would have to give that to you. Please don't sit there and stress over how would I have known the initial velocity. That one would just come at that point. So now when's the diver going to hit the water? Well, when the diver hits the water, how high is it? This is the position. This is where we want it to be. So he's going to be 0. So we are just simply trying to solve this. So I can factor out a negative 16, and I'd be at t squared minus t minus 2. That factors to minus 2 and plus 1. And so that means 2 and negative 1. So he was at the water 1 second before he jumped. Yeah, right. That doesn't make sense. Or 2 seconds in. 2 seconds in is when he would do it. And then velocity at the impact. Okay. So instantaneous velocity now. They want to know exactly when he hits the water, what is his velocity? Fine. I'm going to take the derivative then. So I don't remember if they used an S or what they used, but we'll go with this. Derivative would be negative 32t plus 16 at that point. So we know he's going to hit at 2 seconds. So we'll go negative 32 times 2. I get negative 64 plus my 16. Sorry, I wasn't really leaving it off. So my velocity 2 seconds in. Negative 64 plus 16, I believe that goes to negative 48 feet per second is the rate at which he is falling. Exactly. Now that's not average, that is instantaneous again. Okay, so hopefully that'll help you, and we'll set you free to do your homework.